In this video, we will learn how to identify different laboratory apparatus and discern how and when they should each be used. Let's begin by looking at the different methods available to us for heating things in the laboratory. One method of heating is, of course, the Bunsen burner. The Bunsen burner is attached to a gas tap via some rubber tubing. We tend to use thin-walled rubber tubing for connecting to gas taps. Rubber tubing with really thick walls is for use with vacuum. When we turn on our gas tap, something like methane, or sometimes a mixture of butane and propane, is fed to our Bunsen burner. We can then use a lit splint or match to light our Bunsen burner. Once our Bunsen burner is lit, we have options regarding the temperature of our flame. If the air vent at the base of our Bunsen burner is fully open, this means that we get complete combustion of our gas. This gives us a blue flame. This is a very hot flame and can make a sort of roaring noise. If we rotate the collar around our Bunsen burner, we can close this air vent, and this gives us a bright yellow-orange flame. This is sometimes referred to as the safety flame. Because our air vent is closed, the Bunsen burner doesn't have quite so much oxygen. This means that we get incomplete combustion of our gas. This flame is much less hot and safer to work around. This doesn't make the same roaring noise that the blue flame does. You'll notice that if you try to heat glassware in this safety flame, you'll produce soot on the surface. This is as a result of the incomplete combustion. Generally speaking, our hot blue flame is used for heating things. Once we've finished heating something, we should switch to the yellow safety flame. Of course, if you're no longer going to need your Bunsen burner, it's even safer just to turn it off at the gas tap. Remember that if you're heating glassware over any kind of flame, you should make sure that you're safe by using tongs. Hold your glassware at the end opposite that which you're trying to heat, and always point the opening away from other people. And make sure there's nothing else around the Bunsen burner that could catch fire. That means moving paper away, making sure that you're not wearing anything dangly, and that your hair is tied back. If you need to heat something for a while, it might be that you use a tripod instead. The tripod has 3 legs, though only 2 are drawn in this diagram, and sits over the Bunsen burner. The tripod has a hole in the top, so if we want to stand a piece of glassware on top of our tripod, we need a piece of wire mesh over the top. This means that we could place something like a beaker or conical flask on top of our wire mesh. And of course, don't forget that any time you use a Bunsen burner, whether with a tripod or not, it must always be placed on a heat-proof mat. This is because the bottom of your Bunsen burner is likely to get hot, and we want to protect your work surface. Don't forget as well that the tripod and wire mesh will also become hot. So bear this in mind at the end of your experiment when you're trying to put things away. But the Bunsen burner isn't our only method of heating in the laboratory. For some experiments, it might be better to use a hot plate. These are sometimes called stirrer hot plates. These have a metal heating surface at the top, a temperature dial for altering how hot this gets, and often has another dial which allows you to change how much your mixture gets stirred. The way this works is that this dial alters how fast a rotating magnet inside your hot plate rotates. This in turn alters how fast a magnetic stirrer bar rotates within your reaction vessel. Hot plates can be a better choice than Bunsen burners, for instances where it's useful to carry on heating for a long time, where the stirring could be helpful, or when you're using flammable substances. Of course, if you're using something that's flammable, the last thing you really want to do is be heating it over a naked flame. In this case, a hot plate is much safer. Now that we've looked at heating, let's look at measuring. There are lots of different ways we can measure solids, liquids, and gases in the laboratory. For measuring solids, and very occasionally liquids, we have balances. Different types of balance can weigh substances to different levels of precision. The most common balance is a 2-figure balance, measuring mass to 2 decimal places. For very accurate work, you could use a 4-figure balance. This one is usually encased inside protective housing. Alongside using the balance, you'll need a weighing boat or another open-necked vessel and a spatula. Spatulas, just like spoons, come in lots of different shapes and sizes, so you can pick the most appropriate one. We won't cover how to use balances in this video. For measuring liquids, we have a variety of items. Some beakers have markings of volume on the side of them, so you might think you could measure liquids using that. But beakers like this are incredibly inaccurate, so you shouldn't really use a beaker to measure liquids. Next we have the graduated cylinder, sometimes called the measuring cylinder. These come in a wide range of sizes, from small 1 milliliter measuring cylinders to large 25 or 50 milliliter measuring cylinders. These are reasonably accurate and good for the majority of liquid measurements. However, sometimes you need to be a bit more accurate. For this, we can use the pipette. Some pipettes are straight tubes with lines on them, and these are called graduated pipettes. Just like measuring cylinders, they come in a variety of sizes. They also come in different accuracy ratings. So some pipettes can be made incredibly accurate. If you need a very accurate but slightly larger amount of liquid, you might want to use a volumetric pipette. These are like graduated pipettes, but they have a bulbous centre and only one line. This line is usually right at the top, and these pipettes come in larger sizes, like 25 millilitres. If you're not sure to begin with exactly how much liquid you need, but you do need to measure accurately how much you use, you might want a Buret. These are useful when you need to add a little bit of liquid at a time, but you need to know accurately at the end how much you used. For example, in a titration experiment. Now that we've looked at solids and liquids, what about gases? One of the simplest methods for measuring a gas is with a gas syringe. You simply use tubing to attach one end to your reaction vessel and use the plunger and graduations on the side to measure the volume of your gas. However, you could also use an upturned measuring cylinder or graduated cylinder in gas displacement apparatus. This works just as well, though is a little more fiddly. We've already mentioned several types of glassware, but there are lots of other kinds, so let's look at those now. Perhaps one of the most iconic pieces of chemistry glassware is the test tube, and of course its slightly larger cousin, the boiling tube. These are both useful for doing experiments on small amounts of liquid, though as the name suggests, if you're going to be heating it, it's best to do this in a boiling tube, where there's a bit more room for all the bumping and bubbles. Here are a few other examples of glassware which contain liquids. First we have the Erlenmeyer flask, sometimes called the conical flask because of its shape. The unique shape of this glassware makes it ideal for swirling liquids, because the wide bottom and narrow neck reduces the chance that your liquid will splash out. Beakers are also a common sight. Not good for swirling, but great for containing lots of different liquids and sometimes solids. These have wide necks, so they're useful for maybe weighing out something, using as a waste container, or storing substances that you're going to need later in your experiment. Of course, as with lots of other kinds of glassware, if you are storing something in a beaker, be sure to label it. Chemistry can involve lots of colourless liquids, and you don't want to get them mixed up. Next we have a round-bottomed flask. These are really useful for slightly more complex experiments, or reactions where we need to attach another piece of glassware, for example a condenser. Condensers have a cooling water jacket around them. This helps to condense any vapour that might be given off from your round-bottomed flask. Similar to the round-bottomed flask is the flat-bottomed flask. This is an almost identical shape except that it has a flat bottom. This makes it much easier to stand on a bench or a surface. In order to safely stand a round-bottomed flask down, you're going to need something like a cork ring. Otherwise, your round-bottomed flask is simply going to tip over. Another useful piece of glassware in the lab is the funnel. We can insert filter paper if we want to filter solid particulates out of a liquid, or we can simply use the funnel without the filter paper in order to help us stop spilling liquid when transferring it from vessel to vessel. If we then want to look at the particulates we've filtered out, or do something else in a shallow surface, we could use a watch glass or a Petri dish. A watch glass is simply a shallow glass bowl. These are useful for inspecting crystals, drying some kind of solid, or perhaps leaving a small amount of liquid to evaporate. The Petri dish is similar, except it usually comes with a lid, and it has a flat bottom rather than a curved bottom. Next we have the volumetric flask. These are useful if you need to make up a solution of a set volume or concentration. They come in a variety of sizes, and they all have a line near the top which tells you exactly where to stop adding your liquid for the set volume. They usually then come with a stopper or a bung to sit in the top to stop your liquid from being knocked over or from evaporating. Now that we have all this glassware, we also need some apparatus to help it keep steady. So let's have a look at support apparatus. We've already met the cork ring, which helps hold our round bottom flask. What about if we want to support some test tubes? For this we need a test tube rack. If you look at these from the end, they look like a Z. Along the top, they have multiple slots for different numbers of test tubes in various sizes, sometimes including boiling tubes. Next, we have the retort stand. This is made up of a heavy metal base and a vertical pole. It's sometimes called a clamp stand because we often attach clamps to the vertical pole. In order to attach a clamp to our retort stand, we're going to need a boss. Be careful how you attach your boss to the retort stand. There is a correct way and an incorrect way. This bottom boss is upside down. If you imagine clamping something into this upside down boss, if the screw were to fail, our clamped item could easily fall out and cause a lot of damage. In the correct boss diagram, you can see that if the screw were to fail, whatever you've clamped is more likely to sit nicely in the boss than fall out. The most common thing to clamp in a boss is, of course, a clamp. Clamps are useful for holding all kinds of different types of glassware. Just be sure not to over-tighten the clamp and break your glassware. Also, if you're clamping something horizontally, have the non-moving arm of the clamp at the bottom. This means that your horizontal glassware can rest gently on the clamp and you don't risk over-tightening the clamp and thereby breaking anything. You can also get metal rings to insert into the boss. These are useful for holding conical glassware, like a separating funnel. Whenever attaching apparatus to your retort stand, always make sure that the weight of your experimental apparatus overhangs the heavy base. Never attach your equipment facing the opposite way, as this could lead to the retort stand toppling over and causing a lot of damage. Here we've covered some of the most common items of apparatus in the laboratory. There are, of course, many more items. So if you come across a piece of apparatus in the laboratory that you're not sure about, make sure to ask someone before you start using it. Let's summarise the key points. For heating things, we have Bunsen burners and hot plates. When using a Bunsen burner, we must always use a heatproof mat, and we can choose to use a tripod, mesh or tongs depending on the experiment. For measuring liquids, we could use a Buret, pipette or graduated cylinder. For measuring gases, we have the gas syringe, and for solids, we have different kinds of balance. Other types of glassware that we've come across include test tubes and boiling tubes, beakers, round and flat-bottomed flasks, funnels, watch glasses or petri dishes, and Erlenmeyer flasks. And finally, for support, we have cork rings, test tube racks, clamps, bosses and retort stands. And when using your bosses and clamps, be careful which way round you have them.